no machine intelligence course. There would be no deep networks. So this was definitely a major milestones. 1965, we got fuzzy sets by SYDE from Berkeley. So fuzzy sets was outrageous because 1965 was the beginning, the boom of digital technology. Everybody was showing off that now we can calculate all numbers really accurately. And then a guy comes along and talks about fuzzy sets. What are you talking about? You want to calculate everything accurately, not fuzzily. People didn't get this until the 80s. That this theory is not fuzzy itself, is there to capture the fuzziness. Where is fuzziness? In the human reasoning? When you give navigation instructions to your friend and he wants to park and you say, come, a little bit to the left. What is a little bit to the left? Can you put it in a number for a computer? Can a computer understand a little bit to the left? Or you have to say 13.5 inches. So very important, 1965. And 1969, we basically figured out the limitations of perceptron. These markers are going to be a problem. And of course, you have to take a look at the book by Minsky and Poppert. So this was the idea by Rosenblatt. Minsky and Poppert made it concrete, made it explicit. I said, look, so this is a nice idea, yes, but this problem, that problem, you cannot deal with it this way, you have to do it that way. We got a more concrete of idea, what is a perceptron? What is a perceptron? The smallest artificial neural network that can learn a linear problem. Fundamental, the building block of everything that we have today. So 1969, of course, very important. 1982, we got self-organizing map, thanks to Theodor Kohonen. So this is amazing. This is amazing because it was independent from everything else that was happening toward the backpropagation network that happened after that. Self-organizing maps was, okay, I put a bunch of these processing units that you call perceptron together, and then give the data and say, figure it out. What do you mean? What? Self-organizing. It should organize the data itself without any instruction. That's a crazy idea. How do you do that? Well, by a fundamental concept that we will use again and again and again and again, similarity and dissimilarity measurements via distance metrics. Something that has been around since Sir Isaac Newton. But now we are using it in a different way, applied on big data. Well, then it came 1986. Oh, 1986. The year of backpropagation. Of course, Rumelhart and Jeff Hinton. My story, my journey with AI started here. So I was an undergrad student, and I got a job as a URA, I guess, and said, "Can you read this paper and implement it in ANSI?" I read it. I struggled with it 2-3 months, and I implemented it. I still have the code. I have no idea what was the code doing. So I'm sure I didn't understand half of it. But that was the beginning of my journey with AI. And I said, oh my God, that's so interesting. So the concept of learning. So if you have one processing unit, make it do what you want. That's fascinating for an engineer, to take an entity and say, OK, do what I want. Not just for engineers, I guess. Same year, 1986, we got ID3. ID3 algorithm by H.R. Quinlan.